Hello everybody, and welcome back to the Poor Man's Chemist. In this quick little video, I thought that I would show you guys some complexes of gold that I decided to make. I reprocessed all my gold waste, and why bother keeping it as something boring, right? You know, like chloroauric acid or metallic gold. Let's try to turn it into a cool complex. So, I was reading on Atomistry that you could make this compound called potassium aurothiocyanate by combining auric chloride with potassium thiocyanate at about 80 degrees C, which, happily, this is about the temperature that this is at. So, let's combine these and let's see what happens. Ooh. Okay. Let's make sure not to breathe that. I don't know what that gas is. Cool. Oh, that's a beautiful color. Okay. Yeah, I have no idea what that gas was. Now, there is still some acid left in here from where I had this, I had recovered the gold as chloroauric acid, so I don't know. Some thiocyanic acid, maybe? Is that a thing? Is it deadly poisonous? I don't know. Who knows these things? We're living dangerously today at the Poor Man's Chemist. Oh my God, look at that. Well, you can't see shit. Sorry. Let me bring it here. Oh, yes, we absolutely got a nice red precipitate out of that. Oh, that is awesome. That is so cool. We did it. Ah, that's great. At least I think we did. Oh, yeah, you can see it way better here. Duh. Don't pay attention to me, y'all. I think that's it. Potassium aurothiocyanate. How fucking cool is that? Now, there is another compound that we can make out of this by combining it with silver nitrate, silver aurothiocyanate, since according to Atomistry, this compound contains the aurothiocyanate radical, which is pretty damn cool. So, looks like there's a fair amount in suspension there, maybe some in solution. Maybe I should filter this off and then we'll try that with the filtrate, see if we can't make that silver compound. Oh, how fucking cool is this? This is so neat. Look at that, y'all. The potassium thiocyanate, the residue that was left in the beaker evaporated because it was warm and it deposited these crystals. Look at that. Those are fucking beautiful. Wow. And I didn't even mean to make those. That is really cool. Alright everybody, this is the filtrate from the potassium aurothiocyanate. And what I'm going to do now is I'm going to add a little bit of silver nitrate solution to this, and let's see if we can't precipitate out the other compound. Come on. It's precipitating out something. Oh, there we go. Oh, and that's it for my silver nitrate. So that's going to have to work, but I think we've got it. Try to get all these little floaties here to mix in and make it homogeneous. Come on, floaties. Get in there. Oh, well, there's some stubborn floaties. I mean, obviously, we're outside. There was really no other way I could do it and film it, so there may be some silver breaking down. Also, there's silver... there's chloride in there. And I wonder if that isn't it. Because that doesn't look like silver chloride. That looks like something totally different. Well, let me filter this off and let's see what we've got. Okay, everybody. Actually, I think this is it. I think this is the silver aurothiocyanate. Based on another reference I've seen on Wikipedia, it has what would be about the right color, and it's not decomposing in ultraviolet like silver chloride does. So, yeah, I think that's it. How fucking cool is that? Alright, everybody, here we go for our last gold complex. Now, I was torn as to which one to do, but I figure we can give this one a try. Hopefully it works. Anyway, it is a cesium complex with gold and chlorine, and the formula's on the screen. And the way it's made is we take gold chloride, which chloroauric acid, there is gold chloride in there, and we add a excess of strong hydrochloric acid, or I think it just says it has to be done in strong hydrochloric acid. That should be, I hope, pretty good. As we saw from before, there's still acid in it, and now we need to add an excess of a concentrated cesium chloride solution. Let's really hope this works. Oh, nice. Nothing. Well, that's just fantastic. Huh. Now, the compound is supposed to be red. And we are getting a precipitate here. Oh, look at that. It's red all around that big chunk of cesium chloride. Ah, interesting. Okay. I wonder how much cesium chloride it takes to actually do this. This is going to be one expensive complex. Oh, there we are. We're getting a deep red precipitate. There it is. That's pretty goddamn cool. Okay, I'm intrigued. I'm willing to keep going here. What are we short on? Cesium chloride or hydrochloric acid? Well, darn it, we had it. I mean, we have a precipitate in there for sure. And some of it is red. Oh, alright. That's weird. It didn't look red before. Maybe it's where it's touching the hot plate? Yeah, it's on. We've got some red in there. We've got some yellow in there. What's going on here? Did we get multiple products? Is that undissolved cesium chloride? What the hell is that thing? And we've definitely got all kinds of precipitate in there. I'm going to take it off the heat and let it cool off, and we'll see what we get. Alright, everybody, as it's cooling off, it is going opaque with this orangey yellow precipitate. So it's quite beautiful, actually. I am going to let it settle out here and keep cooling off, and we're going to see what we end up with. Maybe we'll get that red back after all. Who knows? Alright everyone, in the end, this is what I got. This is the potassium aurothiocyanate. This is the silver aurothiocyanate. And this is the cesium gold complex, whose name I'm not even going to attempt. You can see that's a different colored red than what I had before, and what precipitated out, you saw that. That was a much brighter red. But, I mean, after it cooled off and it all precipitated out of solution and I filtered it, this is what I've got, and it is a dark red, so I can only assume that's what it is. So, anyway, I'll cover this up because I don't want the sieves absorbing any water. And I'll just, here is that cesium complex. Here's the filtrate after it was diluted down with some water, and you can see it is a distinct yellow again. So anyway, I'll close out on that. So if you like this video, give it a thumbs up. If you didn't like it, give it a thumbs down. Subscribe, share the video, comment. I promise the next ones are coming. They really are. I am working on them. The next tryptamine chemistry video and the hydriodic acid video. I have not forgotten these things. I am working on them along with 10,000 other things. I have a lot on my plate these days, guys, so I'm doing it as fast as I can, and that's kind of why you're getting simpler but still incredibly cool compounds. So anyway, until the next video, y'all, I will see you later.